Hello and greetings to everyone. We are to answer the following exercise for application under ratios. Question 1 says express the following ratios in their simplest form. For A, we have 150 grams to 12 kilograms. We know grams and kilograms, they are all units of measuring mass. Take solution. Question 1. E, we are to express 150 grams to 12 kilograms as a ratio in its simplest form. First thing we are going to do is we are going to make the units of the two components of this ratio to be the same, either by changing grams to kilograms or by changing kilograms to grams. It is very easy for us to change kilograms to grams. We know 1 kilogram is equal to 1000 grams. Therefore, 12 kilograms will simply be equal to 12 times 1000 grams, which is simply equal to 12,000 grams. If you have problems with these conventions of units, you check my channel, you will see a playlist on metric systems of measurements, and you will learn so much from there on the convention of units. Now let's continue. If we take 150 grams to 12 kilograms, it will simply be equal to 150 grams to, we are going to replace 12 kilograms with 12,000 grams. This will simply be equal to, this ratio has two components. We are going to express it in the fractional form. 150 grams all over 12,000 grams. At this level, we can proceed with simplifications. The grams will strike off 1 0, will strike off 1 0. 15 will go into 15 one time. 15 will go into 1280 times. This will simply be equal to 1 all over 80. The highest common factor of 1 and 80 is 1. That means the two numbers are relatively prime. Writing this as a ratio will simply be equal to 1 is to 80. Therefore, 150 grams to 12 kilograms as a ratio in its simplest form is simply equal to 1 is to 80. For question B, we have 1 kilometer to 200 meters. 1 kilometer to 200 meters. Writing this down, 1 kilometer to 200 meters will simply be equal to, we are going to make the units to be the same by changing kilometers to meters. 1 kilometer is equal to 1000 meters is to 200 meters. Now the units of the two components of the ratio are the same. We are going to express the ratio in the fractional form. This will be this as 1000 meters all over 200 meters. The meters will go off. These two zeros will strike off two zeros. The highest common factor of 10 and 2 is 2. 2 going to 10 5 times. 2 going to 2 1 time. This will simply be equal to 5 over 1. Expressing 5 over 1 as a ratio, it will simply be equal to 5 is to 1. Therefore, 1 kilometer to 200 meters as a ratio is simply equal to 5 is to 1. Go now to question C. For question C, we have 20 kilometers per hour to 20 meters per second. Kilometers per hour and meters per second, they are all units of measuring speed. 20 kilometers per hour to 20 meters per second. For us to answer this question, we are going to express the speed 20 kilometers per hour to meters per second. If we take the speed 20 kilometers per hour, it is simply the same as 20 kilometers all over 1 hour. That's what it simply means. This is simply equal to, we know 1 kilometer is equal to 1000 meters. 20 kilometer will be equal to 20 times 1000 meters all over. We have to express 1 hour in seconds. We know 60 minutes make 1 hour. 60 seconds make 1 minute. Therefore, 1 hour in seconds will simply be equal to 60 times 60 seconds. Now we can carry out simplifications. These two zeros will strike off two zeros in 1000. 2 will go into 6 3 times. 2 will go into 20 10 times, like this. 2 will go into this other 6 3 times. 2 will go into 10 5 times. This will simply be equal to 5 times 10 meters gives us 50 meters all over. 3 times 3 seconds gives us 9 seconds. This is simply equal to 50 all over 9 meters per second. Meters, you must take note of this. Meters all over second is simply the same as meters per second, which can be written as meters times second raised to the power -1. Take note of this. Now, if we take the ratio 20 kilometers per hour to 20 meters per second, it is simply the same as 50 all over 9 meters per second to 20 meters per second. This ratio has two components with the same units, meters per second. Next, we can express it in the fractional form. This will give us 50 all over 9 meters per second all over 20 meters per second. The units will cancel the meters per second. If we divide 50 over 9 by 10 and 20 by 10, this will simply be equal to 5 all over 9 all over 20 divided by 10 gives us 2. Next, we are going to express it as a ratio. Expressing it as a ratio, this will simply be equal to 5 over 9 is to 2. Now we can express this ratio in terms of an equivalent ratio such that there is no 9 at the denominator of the first component of this ratio. If we multiply each of the components of this ratio by 9, we are going to obtain an equivalent ratio, which is 5 over 9 times 9. 9 can be written as 9 over 1 is to 2 times 9, like this. And this will simply be equal to, simplifying the first component of this ratio, the 9s will strike off, we'll be left with 5 over 1, which is 5, is to 2 times 9, which is 18. We are going to conclude the ratio 20 kilometers per hour is to 20 meters per second in its simplest form is equal to 5 is to 18. We are done with the solution of C. We go now to question 2. For question 2, it goes, find the value of x in each of the following. A, x is to 4 is equal to 1 is to 2. You will see that these two ratios, the ratio at the left hand side is an equivalent ratio to the ratio at the right hand side. So we need that value of x such that if we simplify the ratio at the left hand side, it is going to be equal to the ratio at the right hand side. A, we have x is to 4 is equal to 1 is to 2. Looking at the second component of the ratio at the left hand side and the ratio at the right hand side, 4 and 2, 4 is a multiple of 2. If we take 2 times 2, it is equal to 4. So getting an equivalent ratio of the ratio 1 is to 2, if we multiply each of the components by 2, that is 1 times 2, it gives us 2. That means x will be equal to 2. 2 times 2 gives us 4. That means our x will simply be equal to 2. Solving this problem mathematically, we are going to start by expressing the left hand side and the right hand side in the fractional form. This will give us x over 4 is equal to 1 all over 2. At this level, the next thing we are going to do is we are going to perform cross multiplication. We are going to take the numerator of the fraction at the left hand side, we multiply it by the denominator of the fraction at the right hand side. This will give us x times 2. We put the equality sign is equal to, we take the denominator of the fraction at the left hand side, 4, times the numerator of the fraction at the right hand side, 1. X times 2 gives us 2x is equal to 4 times 1, which is 4. Next, for us to get the value of x, we are going to divide both sides of this equation by the coefficient of x, which is 2. 2x divided by 2 is equal to 4 divided by 2. Proceeding with simplifications, 2 will strike off 2. We'll be left with x, which is equal to 4 divided by 2. It gives us 2. We are done with question A. We go to question B. Question B, we have 2 is to 3 is equal to x is to 9. We're going to express the left hand side in the fractional form. 2 over 3 is equal to x over 9. The next step, we are going to perform cross multiplication. 3 times x gives us 3x is equal to 2 times 9, which gives us 18. Next, we are going to divide both sides by 3. 3x divided by 3 is equal to 18 divided by 3. 3 will strike off 3. We'll be left with x is equal to 18 divided by 3, which gives us 6. We go now to question C. Question C, we have 15 is to x is equal to 3 is to 4. We're going to start by expressing the left hand side in the fractional form. 15 all over x. Put the equality sign. We express the right hand side in the fractional form. 3 over 4. Next, we perform cross multiplication. X times 3 gives us 3x is equal to 15 times 4, which gives us 60. Next, for us to get the value of x, we are going to divide both sides by the equation of x, which is 3. 3x divided by 3 is equal to 60 divided by 3. The 3's will strike off. X will simply be equal to 60 divided by 3 gives us 20. This is the value of x. We are done with question 2. We move now to question 3. Question 3. The ratio of the length to the width of a room is 3:2. Find the length of the room given that its width is 10 meters. First thing, we have been told that the ratio of the length to the width of the room is 3:2. We are going to start by letting L be equal to the length of the room and W to be equal to the width of the room. So we have been told that the ratio of the length to the width of the room is equal to 3:2. The next thing, we need to find the sum of the components of the ratio of the length to the width of the room. Sum of components of the ratio is equal to 3 plus 2, which is equal to 5. Simply means out of 5 parts, the length of the room takes 3, the width of the room takes 2. The next thing, the fraction of the room, take the fraction of the length of the room will simply be equal to the component of the length of the room is 3 all over the sum of the components of the ratio of the room, which is 5. The fraction of the length of the room is 3 over 5. Next, we need the sum of the length and the width of the room. Sum of the length and width of the room. It is simply equal to L plus W, which is simply equal to L plus, from the question, we have been told that the width of the room is 10 meters. Put the 10 meters. Now, it is very easy for us to find the length of that room. By making use of the fraction of the length of the room, it simply means the length of the room L is equal to the fraction of the length of the room 3/5 times the sum of the length and the width of the room L plus 10 meters all over 1, like this. We can express L as L over 1 is equal to 3 times L plus 10 meters. Write this as 3 times L plus 10 meters all over, we multiply the denominators, 5 times 1, which gives us 5. Next step, now we are going to perform cross multiplication. L times 5, 1 times this. This will simply give us 5 times L. We put the equality sign, is equal to 1 times 3 times L plus 10 meters. 5 times L is simply equal to 5L is equal to 1 times 3 times L plus 10 meters. It simply remains 3 times L plus 10 meters. Next, we are going to expand the brackets at the right hand side. This will give us 5L to equal to 3 times L gives us 3L plus, put the plus sign, 3 times 10 meters gives us 30 meters. The next step, we are going to transfer 3L to the left hand side to meet 5L. Bring the like terms together. When 3L crosses the equality sign, it becomes negative. This will give us 5L minus 3L is equal to 30 meters. 5L minus 3L gives us 2L is equal to 30 meters. The next step, for us to get the value of L, we are going to divide both sides by 2. 2L divided by 2 is equal to 30 meters divided by 2. The 2 will strike off 2 at the left hand side. We'll be left with L is equal to 30 meters divided by 2 is 15 meters. This is the length of the room. Now we can verify to see if truly L is equal to 15 by taking the ratio of L is to W. If you take the ratio of L is to W, it will simply be equal to 15 meters is to W, which is 10 meters. Next, we can write this in the fractional form. This will give us 15 meters all over 10 meters. The meters will go off. Next, the highest common factor of 15 and 10 is 5. 15 divided by 5 gives us 3 all over 10 divided by 5 gives us 2. Next, we are going to express 3 over 2 as a ratio. Since the numbers 3 and 2, they are relatively prime. This will simply be equal to 3 is to 2, which is what we have been given in the problem, because the ratio of the length to the width of a room is 3 to 2. This is it. So it proves that the length of the room is 15 meters. So we conclude, therefore, the length of the room is equal to 15 methods. We are done with the solution of the exercises for application on ratios. If in case you have any worries, you leave your questions at the comment section. Please like the video, share and subscribe to this channel. Thank you very much for watching.